All right, class.
Yes.
All right, good. So this time, this is my 7th hour. Okay.
Yeah.
Wow. Yay. All right. Okay, so we're finishing up the notes that we have here. This is the Fibonacci Squares. So we're going to actually take a look at the graph paper that we got over here on the back. All right, here we go. So Fibonacci Squares. So there's a pattern to this. Okay, so I'm going to start off by having one square. And you guys have to do it in the same places too, because it makes sense. Next one. Another square. Right off the edge of that one. And now the next one. How big is the next one?
Twice.
It's going to be a 2 by 2. How big is the next one going to be?
2 by 3.
3 by 3. Watch this. 1, 2, 3. How big do you think the next one's going to be? Say it. I got 4s.
6 by 6.
5 by 5. 5 by 5. And where's it going to go?
On top.
On top. I see. 1, 2, 3, 4, 5. Oh, look. Five by 5. How big do you think the next one's going to be? 8 by 8, right? Where'd we get that?
Because the length is 8.
Side.
Yeah. Okay, and it goes where?
Side.
On the right-hand side, right? 3, 4, 5, 6, 7, 8. How big is the next one? 14? 13 by 13. It's going to be 13. So where's that go? On top. Six, 7, 8, 9, 10, 11, 12, 13. There we go. All right. You notice it just keeps getting bigger, right?
Yeah.
Okay, let's try this out then. So I'm going to try this piece out. So how many was in my first one?
1.
How many is in my second one? 1. Don't forget, I also had this square right here, right? How many is in my next one?
4.
It was a 2 by 2, right? So it'd be a 2. The next one would be next one. Next one. Next one.
13.
Next one. 21. Got one person. Okay, someone besides 21. Tell me what's the next one. I heard it. 34. Yes, 34. All right. Besides someone that's already answered, I want to hear some new voices. What's the next one? I heard it. 55. All right, patterns. Time for patterns. So, to get patterns, what do we have? So 1 plus 2 is, or 1 plus 1 is? 1 plus 2? 2 plus 3? 3, 5? 5, 8? 8, 13? 13, 21? Say 34. Whoa, okay, 2134. 55. Now you see the pattern. Add the two previous before, right? Okay, there is a lot of, this is called the Fibonacci sequence. It actually goes into explaining the golden ratio, which happens a lot in nature. Like plants grow in this certain pattern and certain types of things, and the math, it just happens to be like this all the time. Not just nature, but like all kinds of cool stuff. Pacho? I can't leave. Oh, this is not for me. That guy? End of class. Okay, yes.
Okay.
Hey, you with the face. Not you, the other one. Yes, you with the hair. Yeah, end of class. I'm recording, so I don't want to call out your name. Okay, anyway. All right, so just add in the previous two, right? Now, let's go back to our lesson, which is, we should be on the back. And it's asking you, is the Fibonacci sequence arithmetic, geometric, or neither?
Neither.
All right, class.
Yes.
What is arithmetic?
Subtract.
Adding, subtracting, same number. That's important. That's important. Okay, what is geometric?
Multiply and divide the same number.
Very good. Multiplying and dividing by the same number, and neither would be neither of those, right? Okay, so which is this?
Neither.
Neither. It's not adding the same constant thing every time, right? All right, so we're going to nix this because we really don't need that part of this for the golden ratio. If you guys want to actually look it up, you can to figure out the patterns to go along with this. But other than that, that's basically all that we needed to do for this stuff right here. So that leads us to page 16. Page 16 in our interactive notebook. Ah, there we go. Page 16 here. So page 16, I'm gonna help you guys out because some people are struggling with this. Okay, so we're gonna spend the rest of the time on working on practice here, and then I'm gonna tell you guys about the recovery. All right, so watch this. So a hexagon has how many sides? 6. Now I'm gonna set another one next to it. So not this one, okay? Just 1 and 2. So if a person sits, these are tables, at every edge right here, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? There's going to be 10 there. Did I confuse anyone?
No.
If you don't understand, you ought to speak up. So after 3, okay, how many are going to be sitting around the edges on 3? 15? 14? 15 or 14?
15.
All right, let's see. So, watch. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. If you notice, you had to remove one from here, right? If I'm putting a table next to it, I remove this spot, don't I?
Yeah.
Okay, so next one's going to be 14, right? Okay, so does that help you guys out? So we're going to complete the table with this. Describe number of people who sit at the table within each step. Explain why 3.2 does not make sense in this scenario. And define this recursively. Now, recursively means what? You got to have the previous term. And if I'm defining it using the previous term, what notation do I have to add? N minus 1. There we go. All right. So you guys all got work to do. Okay. Don't forget, like, share, subscribe, leave comments below. You could donate to my, I don't know, something, or PayPal account, or